Chapter 5, Motion in a Plane. In last lecture we have discussed about momentum and Newton's second law of motion. In this lecture we will study what is impulse and Newton's third law of motion. See, impulse. What is impulse? Impulse is equal to force into time duration. Force into time duration during which it is acting delta t. And if you know Newton's second law of motion, that is F is equal to delta v upon delta t. So from this you can easily say that F delta t is nothing but delta t, means change in momentum. So yes, this you have to remember. Impulse is equal to change in momentum. A large force acting for a short time to produce a finite change in momentum is called impulsive force. Now what is importance of this impulsive force? See, some very large forces are acting for very small time. So yes, it is difficult to find that force and for that particular time. But for the same thing, for the same phenomenon, we can easily find change in momentum. For example, one bowler throws bowler, batsman hits the ball. So yes, batsman is applying larger force, but contact between ball and bat is for very short time. It is for very short time. So yes, this large force is acting for very small time, and thus it is difficult to find what is that force and that time. But for the same thing, if I know initial speed of ball, I know final speed or final velocity of ball, I know mass of ball, then I can easily find what is change in momentum of ball. Then see, for that change in momentum of ball, I can easily find what is impulse. So yes, here this point you have to remember what is impulse and why this impulse is required. Okay, impulse is equal to force into time duration and is equal to its change in momentum. So in future, whenever you are asked questions to find impulse, yes, you can also find change in momentum. It is easy to find change in momentum. It is easy. Clear about this? Okay. Now we'll see two questions based on it. See, example 5.4. A batsman hits back a ball straight in the direction of bowler without changing initial speed of 12 meters per second. If the mass of the ball is 0.15 kg, determine the impulse imparted to the ball. See what is question. Bowler throws ball. Okay. Batsman hits the ball. In the direction of bowler, straight in the direction of bowler without changing initial speed, means batsman hits the ball in this direction without changing speed of 12 meters per second. It is given speed, but if I want to write velocity, how to write? See, suppose this v1 is equal to, it is 12, and this v2 is equal to, it is minus 12. Yes, here it is plus and here it is minus, that indicates direction. Clear? Because it is in opposite direction. What is mass of ball? Mass of ball m is equal to, it is 0.15 kg. It is 0.15 kg. Clear about this? You have to determine the impulse imparted to the ball. So yes, we know that impulse is equal to, it is change in momentum. Impulse is equal to change in momentum is equal to, it is delta p. Delta p means is equal to p2 minus p1. Final momentum minus initial momentum. It is initial momentum. Okay, p2 means it is mv2 minus p1 means it is mv1. Clear about this? Now m common, so it's equal to mv2 minus v1. Clear about this? What is value of m? It is 0.15. v2 it is minus 12 and v1 it is 12. So yes, it is 0.15 and here it is minus 24. If you calculate this, you will get your answer. Clear about this? Yes. Take care in this step. It is moving with initial speed 12 meter per second. Then how to write velocity? I am taking velocity positive in this direction. Then in opposite direction velocity will be negative. Okay, minus 12. Impulse is equal to, yes, we know that it is change in momentum. Change in momentum means delta P. Delta P means P2 minus P1, final momentum minus initial momentum. mv2 minus mv1, mass to remain same. Okay, m common v2 minus v1, 0.15 minus 12 is equal to 0.15 minus 24. Yes, you can easily calculate this. Clear about this? Okay, now next question. A constant retarding force of 50 Newton is applied to a body of mass 20 kg moving with a speed of 15 meter per second. How long does the body take to stop? How long does the body take to stop? See, a constant retarding force of 50 Newton. Students, whenever you are given retarding force means force in opposite direction. That force you have to consider negative. So yes, here you have to consider F is equal to minus 50 Newton. Why minus 50 Newton? Because it is retarding force. Due to this force, motion of object stops. Okay, if you are given braking force, then that braking force is also called retarding force, and its value you have to consider negative. 50 Newton is applied to a body of mass m is equal to, it is 20 kg. So see, first of all, from this F and M I can easily find one thing, that is yes, acceleration. Then how to find acceleration? Acceleration A is equal to F upon M. F, it is minus 50 divided by, it is 2. 0 cut, minus 5 divided by 2, it is minus 2.5 meter per second square. Minus 2.5 meter per second square. Clear about this? Okay. Now, what question? How long does the body take to stop if it is moving with 15 meter per second? So initial speed V0 is equal to 15 meter per second. Clear? Does the body take to stop? How long does the body take to stop? How long? Means you have to find what is time. You have to find what is time. Yes, you have to find time. What is equation of time? V is equal to V0 plus 8. V is equal to V0 plus 8. Yes or no? Yes or no? Yes. V is equal to V0 plus 8. Okay. Yes, V, it stops. So 0. Initial speed is just 15. 8, it is minus 2.5, and here it is T. So 2.5 T is equal to 15. So T is equal to 15 divided by 2.5. So yes, you can easily find. Also you can find distance. Okay, in which time it stops. So yes, you can use this equation. V square minus V0 square is equal to 2ax. Stops means it is 0. Minus 15 square is equal to 2 minus 2.5, and here it is x. Okay, so yes, it is minus 15 square is equal to 2.5 into 2 means it is minus 5, and here it is x. Minus cancel out. Then x is equal to 15 square divided by 1. So yes, with the help of these two equations that we have derived in chapter number 3, you can easily find in which time it stops after distance. Clear about this? Okay, so yes, this point you have to remember. For retarding force, for braking force, F, that is force, you have to consider negative. And yes, acceleration will be negative. Yes, because it is retardation. Clear about this? So yes, what is impulse? One question based on impulse, and yes, one question based on how to find acceleration, time and distance. Next point is Newton's third law of motion. Now, we know that rate of change of momentum is called force, but how this force is produced? Okay, if I say I have this one chalk, and if I release this chalk, I drop this chalk, it is moving in downward direction. So yes, your answer is, sir, it is moving due to gravitational force of Earth. Means Earth exerts some force on chalk. So yes, you may be asked one question. Okay, sir, if Earth is exerting force on chalk, does chalk exert any force on Earth? Yes or no? If I take another example, if you have a spring, put that spring between thumb and this finger and try to compress this and try to compress it. Okay, then yes, due to this force applied by your finger and thumb, that spring is compressed. But after some compression, you will feel that something is pushing back your finger and thumb in opposite direction. You will feel some force in your finger and thumb. So yes, answer of such question is yes. If there are two bodies, A and B, if on A force is acting due to B, then on also B force is acting due to A. If Earth exert force on chalk, then yes, chalk also exert force on Earth. But why we do not experience this? Because mass of this chalk is very small comparative to mass of Earth. Clear about this? So yes, after some experiments, according to Newtonian mechanics, force never occurs singly in nature. Force is the mutual interaction between two bodies. Forces always occur in pairs. The mutual forces between two bodies are always equal and opposite. So yes, these points you have to remember. Force never occurs singly in nature. They are due to mutual interactions between two objects, between two particles, or between two systems. Okay, yes. Okay, there is friction force when object is in motion with respect to some surface. When object is in motion with respect to some surface, if it is not moving, then yes, there is no friction. Okay, so yes, for kinetic friction, okay, static friction that we will study. Okay, so yes, force never occurs singly in nature. Force is the mutual interaction between two bodies. Forces always occur in pair. The mutual forces between two bodies are always equal and opposite. Okay, as you compress spring, initially the force field experienced by you is small. But if you compress that spring more and more, you will experience yes, force acting on your finger is also increasing. So yes, it is equal and in opposite direction. And with the help of spring example, you can easily understand this concept. So what is Newton's third law of motion? To every action there is always an equal and opposite reaction. To every action there is equal and opposite reaction. Now what do you mean by action and reaction? Action and reaction is nothing but force. Action and reaction means force. If I have two objects A and B, then yes, force on A by B is equal and opposite to force on B by A. Okay, means there is mutual interaction between A and B, and due to which they are acting force on each other. Another point that you have to remember, there is one wrong impression. Okay, first of all, action occurs and then there is reaction. Okay, yes, in daily life we also use these terms, action and reaction. If you are giving some action, then it is my reaction. But see, in this Newton's third law of motion about force, there is no cause-effect relation. No cause-effect relation means action and reaction, they are not acting at different time. Okay, initially action is, and then after some time there is reaction. No, action and reaction, they occur simultaneously at the same time. Okay, so yes, any one of them is given action and another is called reaction. So yes, there is a wrong impression that action comes before reaction, that is action is cause and reaction is effect. That is wrong. There is no cause-effect relation. They act at the same time. They act at the same time. Clear about this? So yes, these mutual interactive forces, they act at the same time. Okay, remember. Next one is action and reaction act on different bodies. On different bodies. What is meaning of this FAB? Force acting on A by B. What is meaning of FBA? Force acting on B by A. So yes, FAB, it is acting on A. FAB, it is acting on A. And FBA, it is acting on B. Clear about this? Okay, these two forces are not acting on single object. They are acting on different objects. So if we consider motion of any one body, only one of the forces is relevant. If I want to study object A, then I have to consider only FAB, force acting on A by B. If I want to study object B, then I have to consider only FBA. But if I want to study the whole system means including A and B, then yes, I have to take their addition, both forces. Okay, but for system of two bodies, they add up to give null force. They add up to give null force. Why? Because what is meaning of this equation? What is meaning of this equation? Equal magnitude and opposite direction. So yes, this point you have to remember. Okay, when we consider system of two bodies, they add up to give null force, means total force becomes zero. Clear about this? And that's why when we have a body is made up of constituent particles. There are always mutual interactive forces, and according to Newton's third law of motion, the resultant of their mutual interactive forces means internal forces we consider zero. Clear about this? So yes, Newton's third law of motion. I know you remember this statement only, to every action there is equal and opposite reaction, but these points you have to remember. Okay, so yes, in today's lecture we discussed about what is impulse, two questions, Newton's third law of motion. Watch videos regularly, make notes, solve your doubts, and yes, do not forget to share, comment and like our videos.